In this video, we'll be covering some more advanced model design techniques you can use to make your model design process go smoothly. Let's begin by opening the Data Model Designer. We've talked about root types and subtypes in previous training sessions, so you should be familiar with them. Today, we're going to look at some best practices you can leverage when creating them. A good model starts with how the types are structured. In most cases, you'll always want to have a base type. Keep in mind, a base type is an abstract term. There's no literal base type in the system. Rather, it's a term used to identify that the type you're working with will be used as a base for other types. To illustrate this, let's look through this data model I've started. At the base, we can see the equipment root type. This has two properties called asset tag and description. Both of these properties are properties that we want every piece of equipment to inherit, which is why we've defined them here and set their modeling rule to create. Next, let's take a look at the subtypes. You'll notice that there's a subtype for other major pieces of equipment defined here. This list isn't all-inclusive of what would be in a real-world process, but it works for illustrating the idea of defining base types for each piece of equipment. At this first sublevel type, each one of these types are generic enough to be used multiple times. Are you going to need more than one motor for your entire process? Probably. What about sensors? Most definitely. In fact, it'd be almost impossible to not need more than one sensor type in any given process you'd be monitoring. So we've made good use of creating types so far, but what about components? How do we determine whether to use a component or just add a property to a type? Since components are just types you've added to another type, you should be able to easily determine where to use them in your model. If I select the motors type, then switch to the components tab, you'll see there's 4 components on it. Each one of these serves a purpose on the motor, and when we think about what they do, we can begin to see how they should be configured. An electric motor will always have a voltage and a current regardless of its purpose, whereas they may or may not have an RPM or driving force that needs to be monitored. In these cases, we've accounted for this by setting the modeling rule to optional. With the help of a component override on each motor, we're able to override the component on our type for the specific motor purpose. In the case of the induction motor, we know for sure that it will have an RPM property that needs to be monitored. So I've added an override onto that component and set the modeling rule to create instead of optional. This override allows you to change the values on the component without affecting the inherited ones from the parent. I've also configured the linear motor this way, except instead of the RPM sensor, the force sensor has been overridden. Now, when assets are generated off these types, the correct sensors will be created. More importantly, let's think about why these are components. All of the sensors in this model are very basic in their configuration, but that won't always be the case. A sensor could potentially have multiple properties that needs to be exposed on it. By creating a type for use as a component, you can define all of the properties you need here, then have them automatically added to another type when the component is added. When you consider the alternative would be to define those properties on each additional type you wanted, it becomes very clear why you'd want to use a component instead. One of the trends you probably noticed is that not only is everything organized in a way that allows you to manipulate the types and assets as needed, but all of these types are organized in a way that you can quickly make sense of as well. To further illustrate this, let's take a look at a larger model. I'm going to open another instance of the Data Model Designer and then connect to a model on my network so we can see how this becomes even more crucial to your model design. Immediately, we can begin to see how organizing these types has a huge impact on your ability to work with the information. It also carries over into your asset structure as well. This is where you'll really see the benefits of keeping your type structured properly. As we can see, the data structure is clear and logical. We almost don't even need to look at the contents of the level to figure out what would be there. This organization of your types allows your assets to follow suit, and it will only increase the benefits as your model grows and becomes more complex. Now let's talk about adding existing assets as components of other assets. Sometimes when you create a component on a type, you do so with the intention of referencing an asset that you've created elsewhere in your model. In this particular model that we're looking at, we've got a great example of why you'd want to do this. On the levels asset, you can see a parent building component that says north-south building. This means that this component is pointing to the north-south building asset. If I remove this, you'll see that it now says unassigned. This means that the component space exists, but it's empty. So how does your existing asset come into play here? Well, in this example, we're working with the building complex. If you're viewing the current floor or level, it doesn't really do you any good to only see level 1 if you have 10 buildings. They're all going to have a first floor, so how do you differentiate between them? You could use a non-relative binding path, but that won't work for mimic templates since the bindings in the mimic templates need to be relative in order to get the data from the asset you've loaded it with. Luckily, you can add any pre-existing asset to your component space as long as the types match. This means that if you add the building to this parent building component like this, you'll have access to everything on the building when working in the scope of the level. More specifically, you've now got access to the data you need from the building so that you can display which building the level is in. Data modeling is a new concept for this field of data management, and a common mistake made is that system architects design their new models based on flawed structures they're trying to get away from. While these old archaic systems serve their users well, if you're going to make the jump to a data model-driven system, you should not limit yourself to what these old systems offered. For example, something like adding a new type if you require it should be an easy process and shouldn't require any major changes in your model. If for whatever reason you think you're going to have a problem later down the road, it's probably wise to take a step back and reevaluate your model structure to see if there's anything you can change to prevent major issues. Let's go back to our model that we were looking at before. If we look at the sensors type, we can see how the structure is configured so that if we need to add another sensor type, we can do so without having to modify anything else in our model. And if we need to add this sensor to another type, we're completely free to do so as it will only affect that type. This type of architecture not only allows you to make changes on a small level, but allows your model to freely grow as needed. This concept is the very essence of what data modeling is all about. To recap, we've talked about when and where to create root types and subtypes, the differences between using components and properties, and emphasizing your long-term goals when designing your model. With this information, you're well on your way to designing a data model that gives you the utmost control over your data. In closing, Status Enterprise is a powerful, easy-to-use tool that lets you design once and deploy multiple times. For more information on Status Enterprise and data modeling, please visit us on the web at www.scada.com.